We are Team 2, and we are focusing on building individual wealth in Yancey County by providing affordable access housing options for the workforce community. Because of Yancey's high housing cost and rent majority, it is difficult for members of the community to purchase affordable housing options and grow connections within the community. My name is Jory Durham, and I am the lead architect on this project.
Hello, my name is Sarah Taylor, and I'm a building science major with a concentration in architectural technology and design.
Hey, my name is Matt Cook. I'm one of the construction management majors. I assisted with POP framework for CLT and the life cycle cost analysis.
Hello, my name is Kyle Grogan. For my job for this project was to implement IPD strategies to the job site.
Hello, my name is John Medford. I'm a construction management major, and I helped with constructability issues and life cycle cost analysis.
Hi, I'm Denton Clark. I was responsible for the project estimate as well as a variety of other market analysis activities.
My name is Casey Beck, and I worked in project management, focusing on constructability issues and IPD management.
Hiya, my name's Emily Malinowski, and I'm a sustainable building systems major.
The main pieces of product data for the new house filter house are as follows. Our client profile for the project is the Williams family, who will reside in Burnsville, North Carolina, on the Glendale parcel. Our building is a 3-bed, 2-bath, 1,933 square foot house. Her scores came in at 0 for photovoltaics and 50 without it. Utility costs average about $67 per month. Construction costs came in at $108 per square foot.
Technical specs. Our assembly incorporates CLT and insulated concrete forms. The foundation has an R value of 13, the walls 24, and the roof has a value of 27. Our HVAC consists of ductless mini-split that is sized to remove roughly 1.5 tons from the conditioned space. The building is PV ready, but our main solution is to invest in off-site PV farms.
Our team's top constraints and goals are affordability, community, constructability, and net zero energy. Affordability is our top goal because we are trying to build individual wealth by building affordable housing options for the lower and middle income residents in Mitchell and Yancey County. Community is our second goal because Yancey County's rent majority hinders community growth. Our affordable access housing option is attempting to foster connections within the community by providing community members permanent housing. Constructability is also a goal for our team because volunteering community members from the Mitchell and Yancey County Habitat for Humanity will be building this house. Our team aims to use modular construction design and materials as tools to aid in constructability for those without prior building experience. Net zero energy is another goal for our team as we aim to provide a building without the need for utility cost. This can be achieved through a photovoltaic solar panel system that will power all the electric needs for the house. These overall goals were reflected throughout our project by making decisions that were informed by these goals.
Our goal is to create a living filter. This integrated concept can be seen through an array of design decisions made to create the filter house. A major decision we made was filtering through materials and selecting those that we supported to be costed in the project. As you can see to the right, CLT is the main material used in an interior finish to the house. CLT represents the filter concept, as it holds an indoor environmental quality, improving the atmosphere through its clean, cohesive visual aesthetic. Another filter you can see to the right is the use of the floor-to-ceiling slats used to filter private and public space, and as a literal filter as it floods the light from the windows to the lower level space. The performance of the building is reflected in the concept of the filter, utilizing sunlight collection through a photovoltaic system to translate into energy. The energy performance targets that were achieved was a HERS score of 0 with PV or 50 without PV. This is a little on the higher side due to thermal mass properties of the primary CLT wall assembly. Our building envelope has relatively low R values, but because CLT's solid mass provides ample thermal massing. The thermal mass is essentially a storage for heat during the day, and then it releases it at night. This is a passive strategy that helps reduce the amount of energy needed to heat the house. The filter house will utilize 2 modular assemblies, cross-laminated timber and insulated concrete forms. The ICFs, being the second wall assembly, will provide a large massed wall, bringing another protective layer to which filters the outdoors from within the house. The filter house will be constructed utilizing volunteers provided by Habitat for Humanity. The great aspect of having modular assemblies such as CLT and ICFs are that they provide ease when assembling with little experience. Skilled laborers required for construction also benefit from the modular assemblies of CLT and ICFs because assembly can be completed in a timely manner and is easy to work with due to its simplistic design. In conclusion, the filter house contributes to the Williams day-to-day life by providing parallels to the ability of the house to function as a tool, to filter work to living life, neighborhood to individual, and ultimately the ability to filter stress to relaxation. Team 2 is honored to represent all of our design teams at Appalachian State University. Please enjoy the following presentations for the new house by the rest of our amazing design students. Thank you.
Hello, this is the new house, Team 6, a net zero energy workforce, affordable access housing for Northwestern North Carolina.
The design for this concept for the new house consists of two primary forms working together to create an L-shaped scheme that provides a cohesive design and carves out pockets for outdoor living spaces at the east and west sides of the structure.
For this concept, the corner lot made it clear that an L-shaped approach would allow for the most cohesive and feasible parameters. The design creates a great separation of public and private spaces, which would be ideal for our client, Catherine Young, who would likely acquire roommates. It is important to ensure that the occupants feel connected to the environment, so we designed a layout that provides ample outdoor living space. The building form is intentionally designed to provide a protective environment in the main outdoor space with the orientation of the private form for the client to safely care for her pets and achieve a sense of privacy while providing a barrier for the wind coming from the northwest. The design strategy is formed for site accessibility and maintaining a relationship between indoor and outdoor spaces, as well as public and private spaces for the client, allowing for a clear flow and narrative for the occupant as soon as they enter through one of 3 entry points. The orientation of the structure allows for the homeowner to make use of the corner lot and become connected to the community around her. Overall, this design is specific to the needs of the town of Burnsville for the explicit purpose of providing access to more affordable housing options for the community workforce there.
The building cost was $143 per square foot with a 17% return on current asset value in the first year.
We were able to achieve a low utility cost monthly rate of $283 with the help of a ductless system with HRV and a mini split, eco panels, a low window to wall ratio, high fixed window ratio, and a photovoltaic system.
Hello, we are Team 1, and during this presentation, we are going to present our team and project highlights of our proposal of the new house in Burnsville to address affordable access housing. Our integrated team consisted of members from architectural technology and design, construction management, and sustainable building system concentrations in the building science program here at Appalachian State University. Our architectural technology and design member, Trevor Cagle, is primarily responsible for creating building information models in Revit and coordinating with team members from the construction and systems group on design. John Garcia was responsible for constructing BIM models and diagrams in SketchUp that effectively communicated project concepts and purpose. Construction management member Matthew Doffelmeyer was responsible for calculating materials and construction costs of the home. Braden Wallace aided in home estimate, gathered detailed information on structurally insulated panels, and examined market analysis information. Logan Ridenauer researched embodied environmental impact, environmental challenges, and assisted in estimation of material costs. Luis Rodriguez also figured material and construction estimates, as well as finding energy efficient fenestrations and appliances for the home. Hunter Chaney established the life cycle cost and analysis in addition to providing information on site, foundation, patio, driveway, and drainage. Our systems lead, Joe Hartung, coordinated with the rest of the team performance against design, address engineering concerns, energy performance, and home comfort and quality. This proposal proves a good option for the new house because it is a compact, square home that is efficient from a building science standpoint, This design incorporates modularity, locating private spaces to the north, a service core, and staircase, which is centrally located, providing ease of access from either end of the home. This home meets the needs and wants of the Rodriguez family, but can also be flexible and expand over time for different families. We would like to thank you all for this great design challenge and opportunity that has been presented to us. It was an honor and a true pleasure to compete. Thank you.
Good afternoon. We are Team 5 representing our new house, Shift. Our team members include Micah Dellinger, Chase Dixon, Jordan Howlett, and Austin Schill from Construction Management, James Matthews, Winter Money, and Pablo Samaniego from Architectural Technology and Design, and Wyatt Pizarros from Sustainable Building Systems. The new house was designed to not only satisfy the prerequisites of the Solar Decathlon Challenge, but to exceed them. Our design, born from an interdisciplinary perspective, was created specifically for the client while maintaining an aesthetic and design sensibility suitable for the Burnsville area. There were many challenges in coalescing all the variables that affected this design from its very inception, but the final product you see here meets or exceeds them all. Using cross-laminated timber construction, the envelope is innovative and sound. The footprint is aligned along the solar path in order to capture as much light as possible through our tall south-facing windows, filling the warm exposed CLT interior with as much light as possible without compromising the efficiency of our wall assembly. Detached flex space allows our clients to explore their passion for woodworking and crafts without encroaching on the living areas, wherein all rooms and amenities are centralized around an open space for dining and lounging. The overall design is very compact in order to bring the cost per square foot down to a very reasonable price for such an efficient building. Despite its novel construction and high efficiency design, the Shift house is absolutely feasible to build and meets all required code.
Good afternoon. My name is Colin Schmid, and I will be presenting Team 3's proposed design concepts for the new house. So here's a little bit of insight into our integrated project team. As you can see, we consist of architects, CMs, and Sustainable Building Systems members. Now our new house we decided to name Opti Home. It is designed for a single mother living in the Burnsville area. Her name is Miss Davis. And we came up with a 1,280 square foot house for her with 3 bedrooms and 2 baths, utilizing advanced framing panels for our wall assemblies. Now, this Opti home, we really wanted to make sure that she felt secure in her house being a single mother. So that was our first priority in design. And secondly, we wanted to bring in as much connection as we could to the outdoor and indoor spaces. So we use daylighting and ventilation to do that. Now, these windows you see here in the rendering are tilt-turn style windows, meaning that they can tilt and turn on a hinge. And by using these types of windows, we can capture the western winds that come through the site to ventilate the entire house. And we believe that this design that we have come up with is a highly functioning, highly efficient home for Miss Davis, which is also affordable and accommodating. Thank you for listening.
Hello, we are Team 4, and we will be presenting our proposed concept for the new house. As you can see, our integrated project team consists of architects, construction management members, and sustainable building system members. Our design is titled the Boone Residence. It's named after our clients, the Boones, which is a couple from Asheville, North Carolina. They wanted to be pioneers in the Burnsville area by developing sustainable yet affordable housing. This concept consists of 3 beds, 2 baths, and features a double-heighted living space on a 1,575 square foot footprint. And now I'll pass it to Ed.
The utility cost of our home came in at approximately $200 per month, a vast majority of which was derived from the electrical bill.
as their home is not equipped with a solar PV system. The remainder of this bill stems from the water. The cost of this building is approximately $107 per square foot, which equates to a construction cost of $154,000. This came in below our budget of $120 per square foot, or $189,000. I'll now pass it to Alex.
For our HVAC system, we're using a single ductless mini split air conditioner, a whole house dehumidifier, and a heat recovery ventilator. In addition to these systems, we will utilize passive building strategies such as extra insulation, staggered stud walls, double paned windows, and southern exposure for solar heat gain. For our electrical systems, we're using low load appliances and all LED lights for a reduced energy load. We're using low flow plumbing fixtures to reduce our water consumption. Thank you.